I'm going to share how we have been using Scala-CLI as a build tool in a real-world project, not only toys and scripts. Before I start, it would be nice if people can raise your hand for the ones that have used the Scala-CLI before, so to get a, what about the audience? Okay. Any of you has used the Scala-CLI as an actual build tool? Okay, good. Then let's hope that you can learn something today. This is a little bit about myself. Basically, I've been working in Scala for a while. Also in Scala.js, I maintain a few open source repositories, like a way for building Chrome extensions in Scala.js, a full stack web application template. I am a consultant, commonly working in multiple Scala projects, etc. I would like to ask you in the audience to think for a few seconds. Why do you actually need a build tool? Think about it. Why? Why cannot use the Scala-C command line and just compile your project? Think about this. It is very likely that the first thing that is going to come to your mind is that in order to write any reasonable Scala application, you will need multiple files, and you will need also external dependencies, because without them, you will have to do a lot of boilerplate, or it might be impossible to do your application. You will be spending the time doing something else. You know that in SVT, we commonly define the build.svt file definition, and we put the dependencies right here. But what you can see at the screen is how you can define dependencies with Scala-CLI, for the people that are not familiar with Scala-CLI. It's just a directive. You might say that a build tool is also pretty helpful in order to prepare your application for deployment, for releasing, etc. FATJAR is a pretty common way for launching the applications. Commonly in SVT, you are going to use SVT assembly, a plugin. But in the case of Scala-CLI, you have the package command that will give you exactly the FATJAR that you are looking for with no plugins at all. You have it right there. No need to install anything else. So you have already resolved dependencies, and you have already prepared your application for deployment with no build tool at all. There are many people that will say that FATJARs are actually ugly and the old school thing, so you will prefer to use Docker because that's the shiny new thing to deploy to Kubernetes or any other thing that launches tomorrow. And Scala-CLI will help you to do that as well. It can package the application as a Docker image. So no need for SVT native packager anymore. You have it right there with Scala-CLI. What about GraalVM native images? It also works. Just provide a different command line option that you will get a GraalVM native image with a Scala-CLI with zero configuration, no build definition, nothing. You get it right there. And also in the Scala world, we commonly use a SVT Scala-FMT plugin in SVT in order to format the source code and verify that the source code is formatted accordingly when executing a CI step. Surprisingly, Scala-CLI already talked about this and included the FMT command that is integrated with the Scala-FMT. That's it. What about providing build information into the runtime environment? Scala version, the platform, or potentially the version of the application, where we usually use SVT dynamic version. Scala-CLI recently introduced a way to expose this information as well. So you have it right there. Now, I would like to ask the audience to raise your hand to the ones that believe that the Scala-CLI can be an actual replacement for one of your projects. Please help me raise your hand. No one? Just a few people. Okay, it's disappointing. Well, a little bit more. So these features are already there. They are already available for you in a single command. Is there anyone in the audience that are familiar with Rust? I know that many people from Scala like to play with Rust. Who of you are familiar with Rust? Cargo? A few? Okay, you can think about the Scala-CLI to be something very equivalent to Cargo from Rust. where it has already everything. It has the linter, it has a compiler, it has a packager, it has a formatter, and quite a lot of stuff. But we do not need to put the cargo.toml file there. Just use a Scala-CLI and you have it right in your hands. And like Adam mentioned it earlier, so is the Scala-CLI an actual build tool? Officially, it is not. But it can behave like one if you use it in this way. It has already all the necessary integrations that you might need for most common projects. And as a consultant, I have worked easily in more than 40 projects with different customers, and I can tell you most of them don't require anything more than the features that I am raising here. But Scala-CLI even provides more. You do not need to define or to install the JVM. Scala-CLI can bootstrap with a custom JVM that you specify in your Scala files. And that's very helpful because you can share something to one person, just tell them, use Scala-CLI, and that's it. They are not going to be concerned about which JVM version you need to use. It just works. So onboarding is simpler. But anyway, it will be nice, and I would like to share a comment that I got from a customer one time. He was being clever because he's a little bit technical and started using ChatGPT in order to replace myself. So he started creating a small HTTP Scala server using ChatGPT. And after he tried to deal with the build.svt configuration to provide, to specify how to do the SVT assembly task, he got to me because he was having issues and ChatGPT was not very helpful. So he told me, hey, can you please fix this thing? I didn't want to mess up with it because I was pretty busy preparing this talk and other stuff. And what I did is I just took the code, the dependencies, prepared a few files with Scala-CLI and shared the file back to him. Told him, just run Scala-CLI in this way and you will get the assembly back and you will be able to test it. Originally, my customer was telling me, hey, you messed up with this thing because it doesn't work. You missed updating the build.svt file, which is the one that I'm having problem with. Then I pointed out about the README that I shared to him and told him, you don't need a build.svt, and he was gladly surprised because he didn't know, he was not aware that you could use Scala with no SVT at all. But the topic of the talk is not about bragging about Scala-CLI, but explaining how we are using it. By now, all of you should be a little bit familiar with Scala-CLI, and I will tell what we have been using it for. One of the most amazing things that Scala-CLI has provided is that we were able to replace most of the bash scripts that we had. Not only that, internally, I use it to work with Ruby, and I liked it for a scripting language. Other persons from my team use Python or JavaScript for writing scripts. I can tell you that now, most of the people in my team are not doing that anymore. They are using a Scala script with a Scala-CLI. And I can tell that over the last year, it was likely the time when I had written the most scripts in my life, because every problem I want to solve it with Scala because now I can use it as a scripting language. Besides that and a few other scenarios, we have also used it for multimodal applications. And I want to highlight this because when I have interviewed with customers, I had a couple of scenarios when the customer asked me, is your SVT knowledge advanced enough in order to create multimodal applications? And the truth is that that's a very simple task with SVT. There is it's not a big deal, but many people are still scared about SVT. So we actually started using multimodal applications using Scala-CLI. There is an open source repository a blog post where you can read a little bit about this. If you scan the QR, you will get to the post. In short, the way that it works, you define a common module where you are putting the code that will be shaded over all the other modules. And we are going to have two entry points in this example, module 1 and module 2, where we have the app.scala, both of them depending on the common module. And there is a Scala package.sh pattern that I tend to put here, and you will see why in the next slides. The structure is pretty simple. Shared code doesn't have too much stuff. It is just exposing a simple function, converting a string to another string, enriching a string, basically. And when we go to the module number 1, what we are doing is using Scala-CLI in order to import the file. We are telling it that we need the file in the scope. That it's as simple as that. And then below, you can see that we are invoking the function that was defined at the common module. The entry point number 2, or the module 2, is exactly the same, just printing a different weird message, and that's it. And this is a scary sh file that I had there, which is a shortcut only. I use this pattern because sometimes we have required to build modules in different formats, some of them supporting GraalVM native images, some others supporting fat jars. So I like to use this kind of shortcut to just define how I am intending to package the application, but it's nothing scary for real. What about the CI integration? How many of you have got to work with Scala projects where the CI actually takes less than 2 minutes? Can you raise your hand? Okay, there are a few people. What about the CI taking more than 10 minutes? Who is familiar with that? The whole audience, almost. Well, with Scala-CLI, the startup time and a lot of stuff gets pretty quick. So in the case of this multi-module setup, there is basically no time spent at the CI. Everything is less than 1 minute. But let's go to an actual real-world usage. In this case, I am taking the case study from codepreview.io, which is a multi-module application that has more than 20 modules. It has more than 5,000 lines of code purely in Scala. We have been using this for the last year, and we have many kinds of modules that are packaged in different formats, which is why I introduced the package.sh pattern. What I can tell you here is that the CI is still taking less than 2 minutes. So forget about the YOLO commit where you just push to master and forget about it because the CI is going to take a while. So I got more disciplined in order to create PRs because the CI is actually fast. Very brief introduction about code preview so that you know just enough for understanding what I'm going to point out later. It's a platform similar to Heroku where you can deploy your Scala web applications with the main difference that you are using Scala-CLI scripts in order to customize the deployment pipeline. If you need a dependency or anything else, it's provided through Scala-CLI scripts, and these are what the modules are for. A demo that, from a live URL that you can see, it's right here. You can see later. And the original version of the code preview scripts workflow was like this. Pushing some code to the GitHub repository was triggering a workflow who executed a code preview script, who executed a bash script, who did many interactions between bash and Scala-CLI, getting a preview URL, which was posted as a comment in the GitHub repository. And I want to highlight the many interactions between bash and Scala-CLI because this is how the project was built when we were just trying Scala-CLI, like last December. The problem is that we built a small CLI application that was compiled with Scala-CLI, and this was executed from bash. So bash was performing the workflow from GitHub Actions, invoking the CLI, getting a result. With the result, we invoked another thing from the CLI, get back another result, and recursively do that for many steps. And at the end, we execute the final deployment through Ansible. What happens here is that bash is a very poorly typed language. Everything is a string, while Scala is a strongly typed language. So even though the solution was very flexible because it was a script and you can do anything you like, it was pretty easy to mess up with the code. There were many weird bugs that we introduced just because of these interactions between Scala-CLI and bash. We decided not to use many bash scripts because it was a little bit complicated for our scenario. Then we decided, after we got confident with the Scala-CLI, we throw all the bash scripts away. Many scripts that were like 150 lines of code in bash were replaced by this thing, just for maintaining backwards compatibility, invoking the Scala-CLI code, and we got into this. Bash is not there anymore. We are invoking Scala-CLI, who is responsible for invoking Ansible and SSH or anything that might be necessary. And there is another thing that I have been working on, but it's not ready yet, which is replacing Ansible with the Scala-CLI scripts. So far, the results are promising, but it's not ready just yet. With this second version, which is more similar to what we have right now, we still have the flexibility that we had before, but we had been able to cut the code quite considerably because now it's Scala. We can just reuse the files, and this also has allowed us to write many critical tests for the application, which is something that we couldn't do with Bash. It was not practical. Another nice thing is that the CI execution time was reduced considerably. We were spending around 5 minutes. Now we are spending something around 2 minutes or a little bit more than 2 minutes, which is a pretty nice thing for the CI with Scala. You might think that not everything is perfect, and that's right. Scala-CLI has a few challenges. It's not a big deal in my opinion. I would personally prefer to try writing full-stack web applications with Scala-CLI only, but the truth is that we depend on the JS ecosystem. And depending on the JS ecosystem is blocking us from doing this because Scala-CLI has no way to deal with this because it's not a build tool. So SVT, Scala.js bundler is the thing that we commonly use, but anyway. There might be a way to get it working, but I haven't actually put the time by writing another wrapper or whatever. But if you manage to use only Scala dependencies, only Scala.js dependencies, you should be able to get away with this and use Scala.js with the Scala-CLI only. I had the impression that this can work pretty nicely with AWS Lambdas. I'm yet to try, but if I can get inspiring you to give it a try, let me know how it goes. That's what I want to try next. You might have noticed that in the files that I have displayed earlier, we are importing the files directly. So when you have 30 files or 50 files, every file needs to import all its dependencies. The entry points in particular need to import all the transitive dependencies, which can be annoying, to be honest. But we had found that this is not really that big of an issue, because we can use the find and replace functionality from the editors, which works quite well. And for the ones that are familiar with Scala-CLI, yeah, there is a project at Scala where you can collect and define all your dependencies, just like you will do in the TOML file from Rust, which actually makes Scala-CLI to be looking like a build tool. But in the particular scenario for us, it didn't work yet because we needed some extra requirements, so we ended up with this annoying thing, but it works. The other potential blocker you might find is that there are no code generators yet. There is an open issue about that. So if you are using something like Protobuf, Smithy4S, or anything else like scalably typed that might need a code generation step, Scala-CLI doesn't support that just yet. It's not necessarily bad. You can actually write a bootstrap script in order to do the code generation before compiling the application, and it works, but you need to be aware of that. In our particular case, we were just requiring to inject some variables at build time. So instead of injecting the variables, we just injected a file, a resource file, and that has been good enough for the scenarios that we are working on. And in conclusion, Scala-CLI as a build tool was totally helpful and useful for us, and I will encourage you to give it a try. You might also have a very nice experience. So thank you.